Okay, so we're going to take a look at 10.3, and this is for Thursday and Friday of this week. And we're going to look at diameters and chords, and I already worked out a couple of these, but we'll talk through them. And so on this diagram, so up here, right, in a circle, if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So it's going to cut, if the chords are equal or the arcs are equal, they both get cut in half. The perpendicular bisector of a chord, right? So if it's perpendicular to the radius, it's going to cut the chord in half, and it would also cut the arc in half. So on 1, 2, and 3, so I would recommend we go ahead and mark the information on the diagram. And so it says the radius is 13. So that means that from P to Q has a length of 13. And RS has a length of 24. But because RS is perpendicular to the radius, that means that that's 12 and that's 12. So that means that I can answer number 1 is 12. And then for number 2, when I want to find what part of the radius it is, you're going to have to draw a radius in. And so it's called an auxiliary line. So we're going to draw this in. But if I draw a radius in, but it doesn't matter if you go from P to S or from P to R, either one of them is fine. So I drew mine from P to S, but it's a radius, so it has a length of 13. But then that makes these little right triangles here, right? So 13 is the hypotenuse of triangle PTS. So I did the Pythagorean theorem because it's a right triangle. So side PT squared plus 12 squared equals 13 squared. So side PT squared plus 144 equals 169. So side PT squared equals 25. So PT has a length of 5. So I can answer that question. But then it wants the length of TQ. But remember that PQ is a radius, and it had a length of 13. And we figured out from P to T was 5. So I took 13 minus 5. So the length of TQ is 8. So let's take a look at number 8. So in circle Q, CD is congruent to CB. So CD has the same length as CB, right? And then, so if those chords are equal, then that would mean that from G to Q would have to be the same length as Q to E, right? So if they're the same, if the chords are congruent, they have to be the same distance from the center of the circle. And so if GQ equals x plus 5, and EQ equals 3x minus 6. So then we're going to set up the equation that x plus 5 would equal 3x minus 6. And then we're going to solve that. So we get 2x equals 11. So x equals 11 divided by 2, or 5.5. Either answer is great. So if the chords are equal, that means they have to be the same distance from the center. So from G to Q is the same length as from E to Q. So that's why we set x plus 5 equal to 3x minus 6.